Here's a pretty standard density type problem where you're trying to find the volume rather than you're trying to create the conversion factor like we talked about in the first example. So here I have my density. Okay, I'm not trying to find it this time, I'm trying to use it. And remember that density is a conversion factor and that I don't really like things written like this. So remember that this is 0.857 grams over centimeters cubed. And that's really over 1 centimeter cubed. Okay, there's our conversion factor. And we can use density because density converts between mass and volume. All right, and in this case, I'm trying to find volume. So if I plan this out, okay, you'll see me do this a lot, okay, where I say, all right, what I'm trying to find is the volume, okay, and maybe I know that just by looking at things, I'm going to look for this in centimeters cubed. Now, it doesn't tell me what unit, so I can select the best unit for me, and since I have grams, I know that those grams are going to cancel, and I'm going to be left with centimeters cubed. So I'm trying to find that, and I'm going to get that from the mass in grams, okay? And the name of the conversion factor that converts between mass and grams and volumes in centimeters cubed is density. All right, so you'll see me set things up a lot like this, where I plan backwards from what I'm trying to find, and you know, I think about what conversion factors I have, and I name my conversion factors. So again, you'll see this a lot. Now, this is just a dimensional analysis problem. I'll show you how to do it algebraically, but for this class, I'd like you to try to set it up as a dimensional analysis problem. So here we go. It's question mark centimeters cubed equals my given. Now, remember over and over and over again, don't start with a conversion factor unless you're looking for a conversion factor. All right, so don't start with a conversion factor. So I'm going to start with my 95.1 grams of wood, okay? And then I do my steps, grams, and I'm going to use density as my conversion factor, which means I can go straight from grams to centimeters cubed. And now keep in mind that I have to put this number in, 0.857 grams over 1 centimeter cubed. Okay, my grams go away. I'm left with centimeters cubed. It's nice and easy. It's a one-step problem. And I get 111 centimeters cubed. Okay, I'm going to use 3 significant figures because this number has 3 and this number has 3. Okay, so there it is, 111 centimeters cubed. Now, what about if I tried to do this algebraically? Well, this is where people start to struggle. Okay, so density, oh boy, density equals mass divided by volume. Okay, now I'm trying to solve for volume. So what I would like to see, algebra-wise, is not just putting numbers in and trying to solve like that, but using algebra like you know how to isolate a variable, okay, and in this case it's volume. So a lot of people try to divide both sides by mass, okay? So I get density over mass equals, okay, now here's the problem. When I cancel these out, what I'm left with is not volume, it's 1 over volume. Oh, okay. So now if I plug my units in, what I'm going to end up with is not, so this is grams per centimeter cubed and over centimeters cubed. Over grams. Okay, so what I'm going to end up with, these grams cancel, what I'm going to end up with is 1 over centimeters cubed. Okay, and that's not what we're looking for. So this whole setup here is just straight up wrong. Okay, and a lot of people try to go about this. when you isolate a variable, that variable darn tootin' needs to be in the numerator, not in the denominator. So let's try again. Just getting some more space here. All right. Density equals mass over volume. Okay. Now, there are two ways that I could go about this. I could cross multiply and divide, or I can multiply both sides by volume. It doesn't really matter. So let's do times volume. Okay, so volume times density equals mass. Then I divide both sides by density. Volume equals mass over density. All right, now in terms of units, I can say that this is the same thing as doing mass over 1 times 1 over density. Okay, and that'll be helpful to me. I'm actually going to use that setup, and you'll see why as we work through this. All right, so volume equals mass over 1 times 1 over density, and then I can start plugging numbers in. So volume equals mass, which is 95.1 grams, over 1, times the density. Okay, now the density is going to be interesting. So this is 0.857 grams over centimeters cubed. Okay, now in order to get rid of these units, okay, I could multiply this by centimeters cubed over grams, 0.857 grams, top and bottom, okay, and what that's really going to do is that's going to move this up to the top. So my grams cancel out, and I'm going to get 95.1 centimeters cubed over 0.857, and that's 111 centimeters cubed. Okay, now if you're good with that step, you can go ahead and stop here. I'm going to show that kind of in a little bit more gory detail right now. So I started with 1 over 0.857 grams over centimeters cubed. Okay, now I want to simplify that, okay, because I don't like having this 1 up here by itself. So I'm going to multiply top and bottom by the inverse of this. So 1 centimeter cubed over 0.857 grams, okay, and top and bottom, 1 centimeter cubed over 0.857 grams, okay. So notice that these actually totally cancel each other out, and what I'm left with is 1 centimeter cubed over 0.857 grams. Okay, so that's how I went from there to just putting the centimeters cubed up top. But again, if you do this as a dimensional analysis problem, it's going to be much better. It's going to be much easier. And we're going to use a similar setup later in the class. So I highly recommend that.